My name is Brysen Pagatpatan. I dealt with sensing and doing the design files.
Hello, I'm Jonathan Insley, and I did the MATLAB script.
Hello, my name is Ian Bunch, and I did calculations for a linear approximation in the Steinhardt-Hart model.
In terms of the project overview, this project utilizes a thermistor and a photocell. We were tasked with utilizing fundamental electrical concepts, an Arduino board, and also developing a MATLAB script to determine the resistance and temperature of these components over time using voltage readings from the circuit. Also, from the data we received from the circuit, we also were able to find other sources of data.
Our project takes a voltage reading from our breadboard and sent it through a serial connection to the Arduino, which then sent it through a serial connection to the MATLAB, which graphs it real time.
For our schematic, it's simply a voltage divider. We have a parallel connection with a photocell and thermistor respectively. The 1 ohm resistor keeps the photocell and thermistor from being given a direct 5 volts. After that, it's just a simple voltage divider where we're interested in using the voltage at nodes A0 and A1 to utilize in our calculations. For the ADC, it takes input from the photocell and thermistor circuit and converts the data to be utilized via MATLAB script for analysis. So in the code you see here, it takes readings from pins A0 and A1 on the Arduino, and then the code uses conversions to convert that analog signal into digital values ready to be used for MATLAB analysis.
For our Steinhardt-Hart model, we calibrate to determine 3 coefficients based on resistance values recorded at 0, 50, and 100 degrees Celsius. Our calculation determines the temperature based on the resistance and the 3 stored coefficients. For our linear model, our calibration determines 1 coefficient based on resistance values recorded at 25 and 35 degrees Celsius. Our calculation approximates the temperature based on the linear coefficient, the recorded resistance at 25 degrees Celsius, and the current resistance.
The first script we have is the main, which is just, it calls UI script. UI script is what we loop around until a global variable is changed. That just started installed. And then we have plot graph, which is the function that plots everything. It has global variable declarations, and it has voltage inputs, and then it has all the animate lines and various labels and such, and then it uses start time to calculate when it's supposed to plot, and it just keeps running. And then we have calc_vals, which is all of our models in MATLAB that declare or calculate the temperature and resistance and such. And then the final model we have, or function we have, is start graph, which basically on a button press starts graphing.
So here we have the Arduino powering the voltage divider with 5 volts at the top, and then you can see that there's a 1 ohm resistor with the thermistor or the photocell in series, as well as a 10k ohm resistor and the alligator grips to measure the analog input to the Arduino. This is the part where we test the photocell, where we test it in dark conditions by pinching it to provide no light, and then providing a light source to see the resistance change when light is applied. Now we're testing the thermistor to see how the resistance changes when we apply an ice pack to test cold temperatures and bring it to 0 degrees Celsius, and then add heat by using a soldering iron to bring it up to 100 degrees Celsius. You'll see in the following graphs these resistance changes and the temperature calculated with MATLAB. Here's where we start to test the thermistor and display the graphs of the resistance and the temperature changing over time. So here we begin graphing the data, and here you can see that we bring the temperature up to 100 degrees Celsius on the left graph, and then once we get to 100 degrees Celsius, we're bringing it down to 0 degrees Celsius. And you can see the other statistics that changed with respect to the temperature applied. Now we begin to test the photocell data that we collect from the voltage divider circuit, and you can see that on the right hand graph that is about to show up, you can see the resistance change and go from high resistance to low resistance depending on whether it's in a light environment or in a very dark environment with no light.
So several steps that we could take to improve this are graph different types of data like current per se. Add an external power source to heat the thermoresistor. Put the circuit on a protoboard through soldering it, and then put that protoboard into an enclosure to reduce the amount of light that the photocell would receive, and rework the code so it doesn't have global variables.